Welcome everyone, and thank you for joining today's webcast about PLE Task Change Management with Pure Variants in Jira. My name is Robert Hellebrand. I'm the moderator of today, and with me as today's presenter, I'm happy to introduce to you Dr. Yang Li from Pure Systems, who is working in the areas of field application engineering and consulting, and is sharing his knowledge about PLE and Pure Variants in tutorials, trainings, and workshops to help our customers on their journey towards a systematic variant management approach. You can find all of our upcoming webcasts on our website. All webcasts will also be recorded and uploaded to our YouTube channel after they have been live. If you have questions during the webcast, please post them at any time in the chat system. Only our webcast team will be able to see your questions, and we will pick them up at the end of the session and answer them. With that, I will now hand over to Yang.
Okay, thank you, Robert, and welcome everyone from my side. So in this presentation, I would like to firstly show you the PLE assets and the corresponding roles to create and maintain these assets in Pure Variants and also other third-party tools. Let's get started. So if you have watched our previous webcast videos, you will be very familiar with this figure shown here. We use this figure multiple times to present PLE assets and their relations. I will briefly introduce this figure here. In domain engineering, you identify features to create feature models, and then you create your superset engineering assets, like your superset requirements, source code, architecture models, and so on. So then you map this superset engineering assets to the features you earlier defined in the feature model to express certain assets are only needed for a variant if certain features are selected for this variant. So in application engineering, you focus on specific variants. You create variant models that contain the features you earlier defined in these feature models. And you can directly make feature configurations in these variant models. And then you can derive the variant-specific assets out of the superset assets based on the feature configuration here. And in the problem space, we talk about variability modeling. We have the feature models and the variant models here, and we don't talk about this how to solve them. So the roles working in this problem space work in pure variants. So they use pure variants to create and maintain feature models and variant models. Now on this right side, so it's the solution space. So where you have the superset engineering assets and where the variant specific assets are located. So the roles who are working on this right side directly work in the corresponding third-party tools. So like DORS Classic, Rhapsody, Camille System Modeler, and so on. And Pure Variants provides this into integration to these third-party tools to interact with feature models and variant models created in this problem space. So engineers working in this solution space, in this solution space, will not use Pure Variants, but stay in their development tools. Okay. So I will use a similar figure here that we have seen in the previous page to introduce PLE rules that are important in this product engineering process. Now let's have a look at a general process when starting a new product variant in the context of PLE. Let's say you have already built up your program, including your feature models and superset assets. And the variant configurator is the role responsible for configuring a variant based on the stakeholders' needs. For example, your customer's requirements. And let's assume a situation to present the workflow. For example, you want to start a new project for a customer. Because you have built up your program and you can reuse your engineering assets, the variant configurator will analyze the customer's requirements to create a new variant model and make feature configurations to meet the customer's needs. Yeah. So during the process, he might be aware of some requirements that are not covered by this existing assets in the program. So he will, for example, use the Jira to create a change request for the domain access engineer who is responsible for the superset engineering access. Yeah, the domain access engineer will think about how to implement this for the program. Yeah, so after the implementation, the domain access engineer needs to restrict the new implementation in the superset access. And Matt used a combination of these existing features to do that. But let's say this time he comes into a situation where no existing features can be used to restrict the new access, and he needs a new feature. So in this case, he will make a change request to the product engineer who is responsible for maintaining the feature model, and then a product engineer will add a new feature to this feature model to finish this task. So afterwards, a domain access engineer knows that there is a new feature created for the new access, and he will use the new feature in the into integration to restrict the new access. And he will close his task of adding a new access to the superset access. And then a variant configurator gets this feedback that the new assets are available, and he can select the new feature for the new product. After that, uh, the variant configurator can derive the variant specific assets. Finally, the variant specific assets can be assigned to the application assets engineer who is responsible for the variant specific assets. So application assets engineer can continuously work on this assets. For example, adding additional things that should not happen at the superset level. Yeah, but it's just specific for this variant because they are not planned for reuse, or the decision of the reuse should be made later. Uh, Moreover, if your program is getting involved and you have a new version of your product assets, the variant configurator can also derive the latest variant-specific assets without losing the local changes made by application assets engineer. And application assets engineer also has the possibility of providing upstream feedback to update this program assets with the local changes. And to make it easy to understand what I will demonstrate later on, I introduce 4 names. Yeah, so Paul, Diana, Victor, and April. Yeah, you can see they are the engineers with a specific role that are just introduced accordingly. Yeah. Okay, now I will show you a running example of how change management related to PLE tasks can be done with this PLE variants and Jira integration. We start with configuring a new variant, and Victor, the variant configurator, will do this part of the job. Okay, now let's say Victor, the variant configurator, has already got this requirements from a new customer. So you can see these requirements regarding, you can see the high beam or low beam, and also fog lights. Yeah. So Victor will analyze these requirements. Then later on, create a new variant model and further make feature configurations for this new variant based on this customer's requirements. And then let's go to this pure variants Eclipse client. You can see Victor will create a new variant model under this configuration space. He will use the context menu and then create a new variant model. And the Victor will firstly give a new name of this variant model. So this time he named it baseline Sweden because this variant model is for the Sweden. And you can see pure variants also provide another functionality named inheritance, meaning that you has this possibility of reusing your existing feature configurations from this existing variant models. You can inherit this feature configurations from this existing variant models. But this time, Victor will do a configuration from scratch. You can see in this newly created variant model, baseline Sweden. Yeah, it contains two feature models. The first one is the functional feature models, and the second one is the feature model holding the sales region features. Yeah. And also pure variance knows all this interdependency information between features. So pure variance can automatically evaluate this configuration result. For example, currently in this variant model, there are two error markers, meaning that if you want to get a valid configuration, you have to firstly correct these two error markers here. And then let's see, Victor will correct these errors. So Victor can directly click this arrow mark, and then he can directly select the feature he wants. For example, he selects the halogen for a low beam and high beam. And then Victor will further select the feature Sweden, yeah, based on the requirements. Victor will also further select another two features. So Victor will continue his work to finish the configuration. But later on, he just found, okay, yeah, there is a new requirement regarding automatic hazard warning. This is a new functionality, which is not covered by the current superset engineering access. Yeah, we need a new functionality. Okay, then Victor will go back to this peer variance, and then Victor can create a new change request by using the Jira integration. You can see Victor go to this my task repository, and then go to new, create a new task. Victor will select this Jira repository, and further select this Carlight project, and then there is a new task created. Victor will give a name. It's a new functionality, automatic hazard warning. And Victor will also set its priority to high, and also change the type to task. Yeah. So I think if you are an expert of this Jira, you might have a better idea, yeah, to fill out all this information here. But in this example, we just keep it simple. So Victor will also write a short description, yeah, to let another engineer know, okay, what is about this new task, yeah. So Victor will assign this task to Diana, who is the domain access engineer. Yeah. So Victor will submit this task to the repository. Okay. Then let's have a look at how Diana, the domain access engineer, will deal with the new task of implementing this new functionality. Here, let's assume that Diana is a developer. Yeah, so Diana will be responsible for adding a new source code of this new functionality into the superset source code. Yeah. Okay. Then you can see Diana has already got this new task. So Diana can directly go into this task to check the description or information here to know what she should implement. Yeah. So Diana will then activate this task because Diana wants to finish his work. So after this task has been activated, so this task can track the changes or track the which elements are related to this task. Now Diana go to this save file and we'll write a new code snippet of this new functionality. Yeah. And here, yeah, Diana found that, okay, this new functionality is an optional one. Yeah, it's not mandatory. So Diana needs a feature to control the existence of this new functionality. So Diana will now save the changes here. Yeah, and then deactivate this task because Diana wants to create a subtask of this main task because Diana needs a new feature. Yeah. So Diana will give a name like create a new feature, and this task will be assigned to the product engineer. Yeah. So Diana will also write a short description. Yeah, we need a new feature to control the new functionality, automatic hazard warning. And then Diana will assign this task to Paul, who is the product engineer who is responsible for maintaining the feature models. Yeah. Then let's go ahead. So now let's see how Paul, the program engineer, will handle the new subtask of creating a new feature. Okay, so you can see Paul also got this new task about creating new feature. Paul can also check the information here in this task, and then Paul will start working, and then Paul can activate this task to track which elements are related to this task. Then Paul will go to the functional features feature model, because Paul found that, okay, the automatic hazard warning is a functionality, should be included into this functional features feature model. And then Paul further decide to create a sub-feature below this driver assistance. And then Paul can create a new feature. Yeah. So now Paul will give a name, a unique name for this feature. Yeah, the unique name is a mandatory one for a feature. Yeah, if you want to have a valid unique name, you can just use this like letters, digits, and underlines. Yeah. And also for this visible name, it's an optional one. Yeah. So if you want to write a visible name, you can write in even in Japanese, in Chinese, it's also possible, just to let you know what this feature is about. Yeah. And then in this example, we just leave it empty. Yeah. So here, Paul also switch this variant type to or. Yeah. Meaning that if the feature driver assistance is selected in a variant, then yeah, you need to further select at least one feature, but you can also select one to n. Yeah, you can select multiple features here. Okay, now let's go back to this Jira task and to have a look at this context tab. You can see in this example, yeah, this context tab contains all these elements related to this task, because Paul has already made some changes in this functional features feature model. That is, he created a new feature, automatic hazard warning. Yeah. So and also, if we double click this automatic hazard warning, you will be automatically navigated to the red feature model holding this feature. Yeah. Okay, now let's go back to this functional features feature model. So if we go to this history view, you can also get additional information here. For example, yeah, you can get the change information. So in this example, the peer variance assets are held in the peer variance model server. The peer variance model server can track the history of changes of these model elements. So since Paul activated this task before making changes, so you can see the active task number for this change is also recorded here, to make sure you can have a full traceability between the tasks and the changes of the model elements. Okay, then let's go back to the Jira task. Now Paul has already finished his task, and Paul can also write a short comment here, like, okay, the new feature automatic hazard warning has been created in this functional features feature model. And then Paul set this task as done. And Paul can also check this attached context, meaning that if there is another user want to check this task, and this user has this possibility of retrieving or recovering this context information into her local task repository, then he can also have a look at which elements are related to this task. Then Paul will submit this task to the repository. Okay, let's go ahead. Now let's go back to Diana, the domain access engineer. So Diana will restrict the new functionality by using this new feature created by Paul. Okay, so now Diana will use this new feature to add a new restriction to this new code snippet. Okay, Now you can see Diana can know, okay, this subtask, task 8 has been finished. Yeah, so Diana can also directly go into this task, yeah, to check the detailed information. For example, the comments here, yeah, Diana can know, okay, there is a new feature, automatic hazard warning has been created. Yeah, she can directly use this feature, and and then if we go back to this context tab, so you can also retrieve, yeah, this context information. For example, we can retrieve this one, uploaded by Paul, yeah, by Paul, and then you can see all the elements that are related to this task will be listed here. And then if we go back to this functional feature model, yeah, you will see also get this information about the change history. Now let's go back to Dana. So Dana will start her work, yeah, because there is a new feature created. So Dana will also activate this task and then go to the red place. So Dana will select this code snippet, yeah, and then go to this toolbar, because Diana wants to add a condition to this new code snippet. So Pure Variance provides this functionality to add this PV's SCL condition to this code snippet. So Diana can directly use this one. So in this condition editor, Diana can start tapping auto. Then if Diana yeah, presses this control plus space, uh, uh, she can directly activate this auto completion functionality. You can see you will get this list here, which knows all the operate logics, logical operators, and also these features, yeah, you earlier defined in the feature model. So then I can directly select a feature, automatic hazard warning here. Then click OK. Now you can see Diana has already placed this one condition here with two command lines here. Yeah, so meaning that if you have this feature automatic selected in a variant model, then the code snippet between this PVSL condition will be included into your variant specific access. Yeah, but if you don't select this feature automatic hazard warning, yeah, so the whole part include this PVSL condition will be removed during the transformation. Okay. Now Diana also you can say comment these two lines. So that means if you want to have a better view or better structure of source code, you don't want to mix this PVSL condition command lines with your real source code of this functionality. You can yeah, comment these two lines, which doesn't affect how it works. Okay. Then I will save the changes here. And then Diana has already finished this work. So Diana can also write a comment here like, okay, the new source code and the new condition has been added. So Diana also set this task as done. And Diana can also check this attached context information. Then Diana will submit this task to the repository. Now let's go back to Victor, yeah, the variant configurator who's starting the change request. So after this change request has been finished, he will generate the variant specific access. Okay. Now you can see this task has been finished. So Victor has already know this part. And then let's assume that in this example, the superset engineering access are maintained via Git, yeah, in the remote repository. So Diana has already pushed this latest version of the superset engineering access into this remote repository. And then Victor has already known that, okay, this task has been finished. And then there is a new version of the superset engineering access, superset source code. So Diana will also use Git to make a pull, yeah, make a pull from the remote repository to his local repository. Then Victor can have this latest version of superset engineering access. So as I showed here, you can see Victor gets this new version of this engineering assets. You can see in this part, he gets this PVSL conditions and also this new code snippet of this new functionality. Now Victor will go to this variant model and to further select the feature, automatic hazard warning for this baseline Sweden, yeah, for this new product variant. And then in this example, because we are using this, Victor is using this pure variance access, yeah, holding in this model server. Victor is using a server project, so Victor can achieve this real-time collaboration, meaning that if someone make a change, yeah, in the feature model, then Victor can directly get this change, yeah. So this is kind of real-time collaboration supported by this pure variance model server. And then Victor will trigger a code transformation to derive the variant-specific codes for baseline Sweden. Okay. Now let's have a look at April, yeah, the application access engineer who will work on this variant-specific access. Okay. Now you can see April has already get this tailored source code because Victor has already selected the feature automatic hazard warning. So you can see the this new code snippet of this new functionality kept here, yeah, without this PVSL or increment lines here, yeah, in the beginning and in the end, yeah, because during the transformation, pure variance will help you to automatically remove this PVSL condition, this criminal line here, yeah, and then maybe during the work, the the application assets engineer, want to continuously work, yeah, on this variant specific assets. This is also possible because April wants to add additional things, yeah, that is only specific for this baseline Sweden for this variant. It is also possible because this one is not planned for reuse. But later on, maybe April and also another decision maker, they want to reuse this part of engineering assets. It is also possible that April can provide this upstream feedback to Diana, to the domain access engineer, to update the superset engineering assets with the local changes made by April, made by application access engineer. Okay, I think that's all about this running example. And at the end of my part presentation, I also want to quickly remind you where you can find all the webcast recordings in the past. Yeah, so they are on the YouTube channel, and if you search for Pure Systems, you will find our YouTube channel. Yeah, so with this different playlists showing our own webcast recordings, and also you can find some recordings from our partners. Yeah. Okay, thank you for your attention, and hand back to Robert.
Okay, thank you, Yang. Thank you very much. And now we have some time left for questions. So let me quickly check whether someone entered a question. And I can see one question here, which is, can you change feature selections in the variant models? Can those changes also be traced to change items in Jira?
Okay, thanks, Robert. And this is a good question. The answer is yes. So in this presentation, we just show that the changes in the feature model, right? Actually, if you use the PRVM's Jira integration, you can also cover these changes in variant models. This is also possible. Thanks.
Okay, as far as I can see, there are no other questions. So let's close the session. Thank you very much, everyone, for participating. Thank you, Yang, for this nice presentation. And hope to see you all again in one of our upcoming webcasts that we will announce soon on our website. Thank you very much, and goodbye.
Goodbye.